everyone, today we're going to have the introduction to complex numbers. Complex numbers are numbers that contain the imaginary part. So that is represented as letter I, which means imaginary. Please remember the following. First, I is defined to be a -1 and I squared is equal to -1. Another thing that we need to remember is that this imaginary I is used to evaluate square root with negative numbers inside of it. Like for example, this one right here, square root of -81. We can evaluate this using the concept of I, imaginary number. So let's evaluate each of these. I'm going to start with square root of -81. So what is the value for this? So how do we evaluate this? So we remember that this square root of -81 can be written as this way. So that is 81 times -1, and that gives us a -81. So 81 times -1 is -81. We can break this down into square root of 81 times the square root of -1. And then square root of 81 is 9. And then the square root of -1 is I. And so the square root of -89 is 9i. Okay, let's try the next one right here. We evaluate parentheses 3i squared. So this means that 3i will be multiplied twice. So 3i times 3i is 9i squared. And we remember that I squared is 1. So then we can go ahead and write 9 times -1, which is the I squared. And so the final answer for 3i parentheses squared is -9. So this is -9 right here. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so what did you have for this? So let's go over this problem here. Again, we can break this down into square root of 25 times -1, and that came out to be square root of -25. And so we can break this down. That's 25 times the square root of -1. So then this comes out 5 times, again, square root of -1 is 1. So that is square root of -1 is I. So I'm gonna write I right here. So then the answer for the third one right here is 5i. And then this one right here would be -4i times -4i is 16i squared. So that's 16i squared. And then remember that I squared is equal to -1. So 16 times -1 is -16. Did you get the same answers as this? We have 5i and -16. Good. Perfect. Now let's have another example here. We remember that complex number is composed of, these are the parts of a complex number. This a plus bi is, we call this as the standard form for complex number. So that's the standard form for complex number. So we call this as complex number, and this is in standard form. Our a here is the real part, and the bi is the imaginary part. So there are two parts of a complex number, the real part and the imaginary part that contains the I. So in this problem right here, we are given expressions that we need to add, complex number expressions that we are supposed to add. I will give you a hint. Adding complex numbers is pretty much similar to adding polynomials. Okay, so we go over the problem here. So we have parentheses 3 plus 2i plus parentheses -5 minus 3i. So this is what we need to do first. We are going to distribute the plus to each term inside the parentheses. So then our expression would come out to be 3 plus 2i, and the positive and the negative will turn into a negative. So I'm going to have -5. Positive and a negative is a negative, so that's a -3i. And then from here, I am going to group like terms. Again, it's pretty much similar to that of simplifying polynomial or adding polynomial. We add like terms. So the constants will be added first. So we get a 3 and we get a -5. Again, our target is to come up with this type of standard form, because this one is not in standard form. They're all over the place. So this one is not in standard form either, because they're all over the place. So it has to be real and imaginary part. So we add those two together. So 3 minus 5 is -2. And then we are going to add the ones with the I, or the imaginary part. So that is positive 2i minus 3i is a -1i. So I can just go ahead and write minus I. So this is already in standard form. Again, this one is the real part. And this one right here is the imaginary part. So it matches up with our standard form. So that is the real part. And then this is the imaginary part. If you have this as your final answer, that is not reduced in standard form yet, be sure that you combine like terms. Let's move on to the next one over here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. It's pretty much the same thing as what we did over here. We are going to distribute the negative to each term inside the parentheses, so that this would come out -7 minus I plus 4, because you have a negative times negative is a positive 4, and the negative times positive is a -5i. And then from here, we do exactly the same thing as what we did over here. We combine like terms, so we combine the constants or the real part. So that is -7 plus 4 is a -3. And then we combine the imaginary part, that is -1i minus 5i is a -6i. And so this is already in standard form. This is the real part of the complex number. This is the imaginary part. So as you can see, it matches up with this. If you have this again as your answer, that is not in standard form. It has to be similar to that of standard form that I put inside the red box over there. Now let's have another example here. So what about if we get this type of problem? So we have, it's pretty much the same thing. They're all being set up. All we need to do is to come up with a standard form, a plus bi for complex numbers. So pretty much we just have to combine like terms here. So the 7 plus 4 minus 1. So 7 plus 4 is 11. 11 minus 1 is 10. So I got 10. And then I am going to combine the imaginary part. So that is -2i plus 8i would come out to be 6i. That's a positive 6i. And this is the standard form. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We use the distributive property. This is not in standard form because there's a parentheses. It has to be real and the imaginary part. So then from here, we can go ahead and distribute the 3 to each term inside the parentheses. That would come out 15 minus, that's 3 times 5 is 15. 3 times -2 is -6i. Did you get 15 minus 6i as your answer? Good. Perfect. Now let's have the last example here. So let's take this last example here. So we are supposed to multiply these two complex numbers. Both of them are in standard form, but when we are supposed to multiply them. So this parentheses is telling us that we are supposed to multiply them. So to do that, we are going to use the area model for this, or the box. So I'm going to write the box over here. So, and then I'm going to write 3 and then 2i, and then on this side 5 minus i. So it's pretty much like doing the same thing as what we did on binomial. So this one right here would be 3 times 5 is 15. This is negative 3i. This is 10i. And then 2i times negative I is negative 2i squared. And then we can combine like terms. So the diagonal here are the like terms. So I get 15. So that's 15. Negative 3 plus negative 3i plus 10i is 7i. So that's plus 7i minus that's 2i squared. We remember that I squared is equivalent to negative 1. So then I can change this is not in standard form because we have an I squared over there. But we remember I squared is negative 1. So 15 plus 7i minus 2. And then again, I squared is negative 1. So then we can go ahead and multiply these two together. So that's 15 plus 7i. Negative 2 times negative 1 is a positive 2. So then the final answer for this is 17 because we have a 15 plus 2. So I'm just going to combine like terms here so you see what happened. So that would be 17 plus 7i is the final answer. So this is in standard form already because we have, this is the A part and this is the BI part. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem that you have here. We can actually solve this using FOIL method, but let's to be uniform with the rest of the work that we did from the past. We're just going to use the area model. So in here, we will have this is gonna be, we use the box here, and then we write the terms here. So that's negative 1, 3i, and then 4, and then 2i. So I'm gonna write that over here. So that's negative 1, 3i, 4, 2i. So this is negative 4. This is 12i. This is negative 2i, and this is 6i squared. So then we add the diagonal, we add like terms. So this will come out negative 4. And then negative 2i plus 12i is positive 10i. And then we have a plus 6i squared. Okay, so we remember that this is not in standard form because we have an I squared. It has to look similar to this. So then we go ahead and remember that I squared is negative 1. So negative 4 plus 10i plus 6 times I squared is negative 1. So then we go ahead and write negative 4 plus 10i. Positive 6 times negative 1 is a negative 6. Negative 4 minus 6 is a negative 10 plus 10i. And this time around, we got the standard form for complex number. Did you get this answer that we have over here? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!